Okay, so we're going to continue this problem. Again, this is 311 from the Hibbler text. Looking for the tension. I'm looking for W, which we've tied W to TCAD, and I can only put 80 pounds in these two cables, AB and CAD. Now, I've got a free body diagram involving those two cables, AB and CAD, or BA, whichever way you want to write it. I don't know why I wrote it BA here. You could write it AB. The same thing. You could write it ACD if you like, if you're OCD. Sum of forces then in the x direction, that's going to be 0. In the positive x direction, I've got TCAD sine theta. And the negative x direction over here, so minus, I've got TBA, and this one's going to be sine 20. And then I've got sum of forces in the y directions equal to 0. Well, in the y direction going up, I've got TBA cosine 20 degrees. And then going down, so minus, I've got this TCAD right there. No angle on that one, so it's all in the y direction. And I've got part of this one over here. So this one's also minus TCAD, and this one's going to be cosine the unknown theta. So if you look at these two equations, then I've got three unknowns. I don't know theta, I don't know tension BA, I don't know tension CAD. However, I do know one thing. I do know the most that any of them can be is 80 pounds. We said earlier, problems involving max tension allowed in multiple cables. Solve the problem multiple times, but set one cable equal to the max tension. Or if you can, figure out which one is the most likely, which one's going to have the most tension in it, and set that one equal to your max and solve. That's a little more challenging. The easier one is probably to just pick one of these and set it equal to the 80 pounds allowed and solve for the tension in the other one and see if we've exceeded that maximum limit. Okay, so all that to say, I've got a way of getting it down to two unknowns. If I say one of these is 80, then the other one is unknown, and now I've got two equations, two unknowns. That should be solvable. And when you've got an unknown angle, sometimes these you're going to have to involve some trigonometric identities that you're probably going to have to go look up. I had to go look one up today, and that's okay when you have to do that. So let's get where we can with this. So what do I do here? I said that if you'll solve this first one, and I'm going to solve this first one for TAB, or TBA. Okay? So if I solve this first equation, and say, well, this is TBA this is sine 20 degrees. TBA sine 20 degrees is going to equal TCAD sine theta. And by the way, if you ever like it, you're like, Steve, I don't want to write everything out. I just want to, this is a number. Sine 20 is a number, right? You can just calculate it and just carry that around. If it's something like sine 30 or sine 60 or sine 45, to where it's like an actual number, rad 2 over 2, 0.5, 1/2, or rad 3 over 2, then those are real easy if you want to convert those anytime. But if it's sine 20, that's not going to be like a discrete value. You may or may not want to convert that now because there's going to be a round-off error. I'm going to leave it, but if you wanted to write like 4 significant figures or whatever this is in a number, that's okay. Nothing wrong with that. Just be careful how you do it. Okay, I'm going to leave it as sine 20 for right now. We'll see why in a second. So what does that mean? That means, well, if I find TBA, then that's going to be TCAD sine theta divided by sine 20 degrees. Okay? So if I plug that in here, and that's normally how I would try to do some algebra, right? Solve for one unknown, plug it in to another one, and see if I can simplify it. So if I take this and I plug it in here, so then I get T CAD sine theta all over sine 20, and again I'm plugging this in for TBA right here, so it still gets multiplied by this cosine 20. Okay, and that's going to equal then, so I'm going to move these two terms, I'm going to add them to the other side of the equation, so that's going to equal TCAD plus TCAD cosine theta. Okay, well, something neat happens here. Notice TCAD shows up in all three terms. So long as TCAD is not 0, I can divide each of these terms by TCAD, the tension in CAD. So long as it's not 0, then this becomes sine theta over sine 20 cosine 20 is equal to 1, TCAD divided by TCAD, and then plus cosine theta. Okay. Now I know this looks like a mess. It is, a bit. I'm going to multiply everything by sine 20. Get this sine 20 on the other side of the equation. So now I've got sine theta cosine 20 is equal to the sine of 20 plus the cosine of theta times the sine of 20. Sorry, you couldn't see that. There we go. So again, I've just taken the sine 20, moved it to this, distributed to this side of the equation. So multiply the 1 by sine 20, multiply the cosine 20 by sine 20. And here's where I kind of hit a brick wall, because it's been a long time since I've taken trig. But I was like, well, there's got to be some kind of angle. Well, sure enough, there was this idea that if you take sine theta cosine 20, and you subtract this guy, subtract cosine theta sine 20, that's going to equal sine 20 degrees, and there's a magic trigonometric identity that we can apply here that says, and here, this is not the kind of thing I would expect you to remember on a test or something like that, because it's probably been a while since you've used it. I had to go look it up, but there's an idea that the sine of A minus B is equal to the sine of A cosine of B minus the cosine of A sine B. Well, notice what I've got here. If I say A is theta and B is 20, right? This works. So then this becomes, so if I say A is theta and B is 20 degrees, then the sine of theta minus 20 degrees is equal to the sine of 20 degrees. Also, if the sine of C is equal to the sine of D, then C is equal to D. So another neat thing, if I've got a function is equal to the same function with different arguments, then the arguments must be the same. It's a standard rule. It can be exponent, sine, just about any, logs, just about anything. Okay? So that means theta minus 20 degrees is equal to 20 degrees, or theta is equal to 40 degrees. Now theta's known. And that's one of the things the problem originally asked for. That's one of our answers. Okay, awesome. Now, what the heck are we trying to find? Well, that's why we write it all the way back up here. Right? What the heck are we looking for? Well, we come back to the very beginning of the problem. What are we looking for? We're looking for the weight. Okay. We know the tension in AB and CAD can only be 80 pounds. And we're also trying to find theta. Well, good news is we found theta, but we're also trying to find the weight. Now, how do we find the weight? Hazel's snoring pretty good over there. I'm sorry if you can hear that. We're also trying to find the weight. So the weight here is, again, equal to the tension in CAD. So can I find the tension in CAD? Well, again, I've got now two equations, two unknowns. I know the tension in BA is related to the tension in CAD. I now know theta. And I know only one of these can be 80 pounds. The other one has to be less than that. So you can do it a couple of ways now. You can do this a couple of ways. You can say that if TBA is equal to 80 pounds, and then the fact that TBA we found earlier is equal to TCAD sine theta, which we now know theta, divided by the sine of 20. And if I let this be 80, and I solve for TCAD, go ahead and pause now and do that on your own. I'm about to write down the number, though. Right. Well, if we do that, then TCAD has to be 42.6 pounds. So if we look at that and say, well, if this one's maxed out at 80 and this one's only 42.6, that means it's less than 80. So this becomes the answer. So that means the weight, which is equal to TCAD, and it doesn't max out, is equal to 42.6 pounds. And this becomes my answer. I'm going to write a note down here. I intended to actually say to do it the wrong way first, so we had to do it the right way. Note that if we let TCAD be the 80 pounds, you would find tension AB to be approximately 150 pounds, which means TCAD cannot be the 80 pounds because this one can't be 180 pounds. So if we started here and we say, well, let TCAD be 80 and we solve for TAB and we found it to be greater than 80, that means then we'd have to go back and do this one then. We'd say, okay, well, let's let the other one be 80 and solve. And that's where we find the answer. That's a good length. I'm going to stop there. But ask me questions. Seriously, send me an email, write me comments down there, because that's not an easy problem. Let me know what's not clear to you, okay? All right. Keep up the good work, guys.